Of slides here is the wrench the gentleman was using to take the valve off the cylinder. This just shows the valves fitting on the cylinder. This is a chain vise he was using to hold the cylinder on the workbench. And when the cylinder exploded, just ripped the chain right off the vise. And the cylinder bounced around. Here hit the workbench. You can see the workbench is pretty much damaged here. And this item on the workbench just happens to be the gentleman's watch that was ripped completely off his arm, and his arm was severed completely between the elbow and the wrist. This is where his severed arm landed, and this is a picture of where the cylinder valve and cylinder landed. A close-up of the cylinder valve shows the markings of where the adjustable wrench was on the valve. You can see, if you look a little closer, you can see that the force of the explosion was so hot that it melted the cylinder valve on the inside of the tank. This is a piece of shrapnel from the top of the cylinder. This is another piece of shrapnel from the top of the cylinder. You can see it's pretty much flattened. Remember, this is an E cylinder, showing how sharp the edges are. This again is the cylinder itself, looking down inside the cylinder. And where did the top of the cylinder go? Well, it embedded itself in the pegboard on the wall across the room. The explosion was so hot that it melted the inside of the top of the cylinder, and it also melted the threads where the cylinder valve attached.
This compression of gas represents a tremendous amount of stored energy. If the outlet valve is broken off, the sudden release of compressed gas can turn the cylinder into a missile with energy to shoot through a cinder block wall.
Driving up the temperature and pressure of the gases inside the cylinders. At about 3:20 p.m., increasing pressure inside one cylinder activated its pressure relief valve. Gas pushed against the spring-loaded plug, allowing propylene to flow around it. Gas moved past the spring, out of the valve, and through openings in the cylinder cap. The propylene vented to the outside air and formed a flammable vapor cloud around the top of the cylinder. A static charge, created by the venting propylene, most likely ignited the vapor. A Praxair security camera recorded the vapor release and ignition. The vapor begins escaping from the cylinder seconds before 3:20 p.m. It ignites immediately. An employee sees the fire and sounds the alarm. Within 30 seconds, the fire is spreading rapidly, heating surrounding cylinders, causing them to vent gas, adding more fuel to the flames. Just over 1 minute after the initial vapor release, smoke begins to darken the facility as the fire rapidly grows out of control. 90 seconds into the incident, the camera records blinding flashes as cylinders begin to explode. Cylinders begin rocketing through the air, further spreading the fire.